For most of history, neuroscience has thought two things. One, that the brain stopped developing after childhood, and two, that brain damage was permanent. Modern neuroscience has proven those to be false in their entirety. Let me explain. Before we dive into that, let's define what we're talking about. We're talking about neuroplasticity. Neuroplasticity, as a fundamental idea, is the brain's ability to change its function and structure over time, based on the stimuli you expose it to, extrinsic, whether it's extrinsic or intrinsic, your environment, and even your own thoughts, can physically restructure your brain. Let's dig a little deeper on how the brain actually changes. It changes in one of three ways: through synaptic plasticity, neurogenesis, and neuroreorganization. Synaptic plasticity is the idea that the connection between your neurons can either strengthen or weaken depending on the reasons I listed before: stimuli, experiences, environment, your own thoughts, etc. Neurogenesis is exactly what it sounds like: your brain's ability to create and generate new neurons. Neural reorganization is the fundamental idea that neurons can reorganize themselves. Axonal sprouting can create new connections, fundamentally changing the structure of your brain. The fundamental idea here is that the brain can rewire itself, that the brain has the ability to change over time. How do we know this, you may ask? Well, let's talk about brain injuries, whether from strokes or TBIs, etc., etc. A brain injury has three recovery phases. Phase 1 is going to be the first 48 hours. This is going to be your initial damage, your initial cell death, the region of your brain actually being impacted, the major fallout from whatever event just occurred. After that, you're going to have phase 2, and this is going to be your early recovery phase. This is the first couple weeks after the initial injury, and this is going to be when your support cells are activated, your synaptic plasticity is going to increase, and your neural connections are going to start trying to reform. And then you have phase 3. Phase 3 is the long-term recovery, and this is weeks to months after the initial event. And this is going to be when your brain really tries to put itself back together, and when it finally has the time and resources to start healing fully. This is going to include your neural networks reorganizing, axonal sprouting is going to start forming new connections, and in probably the most fascinating part, the brain regions that were not impacted will try and compensate for the region that was. An example of this is a hemispherectomy. A hemispherectomy is when, obviously, you remove half of the brain. One region or one hemisphere of the brain is removed. And when this is done, it's been shown in studies that the remaining hemisphere and remaining regions of the brain try and compensate for the functions that the missing hemisphere handled. Another way to say that is the regions of the brain that were left tried to create the functions or create new neural networks to handle the functions that your other region that is now gone handled. And that's a fascinating topic, because that means that the brain has the ability to recognize what's missing from your normal body operations and try to compensate for that in regions that should have no say in what those functions do. Another example of this is mirror therapy. You may have seen some of these videos online where you hold a mirror up, especially for people who are missing a limb, and you can, and this is mainly to help with phantom pain, but it's also an idea of how the brain tries to compensate, because when you have the mirror up and you don't really have this other limb moving, but your brain thinks you do, it's a wildly complicated topic, but stimulates your brain to at least try to form new connections and new ways to think about stuff. The key takeaway from this is that the brain can reorganize itself, can change its structure, its functions, its whole identity to try and compensate for lost function or to generate new function. Okay? Now, bring it all back together. We just talked about how the brain changes throughout time. Even after adulthood, the brain is constantly reorganizing, restructuring. This on its own proves that, like I said in the beginning, the brain changes after childhood. And then we talked about brain injuries and how missing or remaining regions of the brain can compensate for the missing or the damage. It doesn't have to be missing, but a damaged region that can no longer perform its intended function can have help from other normally functioning intact regions. Which means through neural reprogramming and neural reorganization and neuroplasticity, we can help patients with brain injuries restore their lost functions through stimulus training, which I think is pretty incredible.